Okay, we're looking at converting between fractions, decimals, and percentages. So we're going to start off with the nicest of the six combinations. That's going to be decimals to percentages. So let's talk about pizza, right? So, if I've got one whole pizza, well, I've got 1.0 pizzas, right? I've got one pizza. This is the exact same as having 100% of my pizza, right? I've got 100% of a pizza. And so because these things are the exact same, they're just different ways of talking about the same thing. I know that 1.0 is the exact same as 100%. Well, how do I get from 1.0 to 100? All I do is I times by 100. And in general, that's what we do, right? Imagine we've got 0.12. I can times this by 100, and that should give me my percentage, right? I just move this whole thing up 2 spaces, or the decimal point will move down 2 spaces, and it'll end up there. So I get 12%. So that's our decimals to percentages. Decimals to fractions. Let's stick with this example, right? Let's stick with 0.12. And if I want to convert this into a fraction, well, I could be super lazy and just write this as 0.12 over 1, right? That's technically a fraction. But we don't tend to want to have decimal points in our fractions. So what we can do is we can make sure that we kind of get rid of this decimal point. Well, how do I do that? In this case, I can times it by 100, right? I can times the top and the bottom by 100. I know that becomes 12 and the 1 becomes 100. And this is a much better looking fraction now. We could simplify further. So I've got a common factor of 2 in the top and the bottom. I could divide them both by 2 and I get 6 over 50. I can do the same thing again, divide by 2, I get 3 over 25. And that would be my answer. Converting between fractions and percentages next. So this can be nice or horrible, depending on what the question is. We'll do a nice one here and we'll do a horrible one here. So these two methods are very similar. So let's start off with maybe 3/8, and we want to convert this into a percentage. Well, we can, even if we don't know what 1/8 is, we're going to kind of work up from the bottom and kind of add our way to getting 3/8. We know what a half is, right? We know a half is the exact same as 50%. We know a quarter is the exact same as 25%. We're just halving both sides. I can halve both sides again, and I get an eighth. So I get 12.5%. And so I can think of 3/8 as just 3 lots of 1/8, right? It's just 3 lots of 1/8. So I can think of this as 3 times an eighth. Well, I know what 1/8 is. I know 1/8 is 12.5%. I've just worked that out here. So I can think of this as 3 times 12.5%. And that gives me 37.5%. And that would be my answer. That we're kind of using our fundamental understanding of what a half is 50%, to kind of get to the stage that we can then kind of count up in eighths. Converting fractions to decimals. So very similar to fractions to percentages, because we know decimals and percentages are very similar. They're just 100 times separated. So fractions to decimals. Let's look at a more horrible question. Let's go for, say, 19 over 60. Well, this is just 19 divided by 60, right? A fraction is just the same as writing 19 divided by 60. And what do we do when we've got this? Well, normally when we do division, we take our number, we put it under the bus stop, and we do the bus stop method. And I'm going to give myself a few extra zeros, because obviously 19 is smaller than 60, so we're going to continue on down into our decimal places. So we do 19 divided by 60. Well, first of all, we do, does 60 go into 1? Nope, it doesn't go. We carry the 1. Does 60 go into 19? Nope, it doesn't go. We carry the 19. And then we do 60 into 190. Well, I know 60 times 3 gives me 180, right? So I know that 3 60s can fit in total. I've got a remainder of 10. And now I do 60 into 100. Well, I know that 60 fits into 100 just once, with a remainder of 40. I now do 60 into 400. Well, because I know my 6 times tables, I know 6 times 60 is 360. So I can put 6 60s into 400 with a remainder of 40. And I've just done this, right? I know 60 fits into 400 6 whole times with a remainder of 40. And what we find is we're basically stuck in this never-ending loop, right? We can keep basically doing this and adding on 6s. Well, we've basically solved it, right? We know that our answer is therefore going to be 0.316 recurring for this one, because we just get never-ending 6s. Percentage to decimals. This is quite nice. It's just the opposite of this. From decimals to percentage, we times by 100. From percentage to decimals, we just divide by 100. So, for example, 12%, we just divide this by 100. Obviously, that decimal point next to the 2 is going to shift up 2 spaces. We're going to end up with 0.12. And, obviously, that's the same as what we started with here. So we're just kind of going back the other way. Finally, percentages to fractions. This is very similar to percentages to decimals. Let's do an example. Let's say we want 56%, and we want this as a fraction. Well, percent just means per 100, right? So I can think of this as 56 per 100, or 56 hundredths. And that's what this is, right? Obviously 100% is just 100 over 100, which is just 1, or 1 whole 1. So we've got 56 over 100. We've got our fraction here, right? But we can probably simplify this down. We've got a common factor, I can see, of 2 in the top and the bottom. So I could write this as 28 over 50. I could write this, again, common factor of 2. This is going to be 14 over 25. And I think that's as far as I can go. There's not any more common factors. Right, let's do a couple of exam style questions. So we'll look at 54% as a decimal. Well, we know how to do this, right? We know that 100% is just equal to 1. And so I know that to convert between the two, I've got to divide by 100. Well, in this case, 54.4 divided by 100 is going to give me 0.544. And it's as simple as that, if you can read my fours. 0.256 as a fraction. Well, again, we can be really lazy and just write this as 0.256 over 1. That's technically a fraction, but we don't want to have any decimal places or decimal points in our numbers. So how can I get rid of this decimal point? Well, at the moment, if I look at this, I've got a digit in my thousandths column. And so to get all 3 digits out of being on the right of the decimal point, I've got to times by 1,000. And so I can times by 1,000 on the top and the bottom. This is going to give me 256 over 1,000. We can simplify further, right? We've got a common factor of 2. We could write this as 128 over 500. Again, I've got a common factor of 2. This is 64 over 250. And again, I've got a common factor of 2. This is 32 over 125. And I don't think I can go any further than that. So that's going to be my final answer. Finally, 17 over 40 as a decimal. Well, just like we did before, if we think of this as basically 17 divided by 40, well, all we're doing here is bus stop method, right? We've got the bus stop, we're doing 17.000, because we know we're going to probably need some decimal numbers, divided by 40. Well, 40 goes into 1, 0 times. It goes into 17, 0 times, so we carry the 17. It goes into 170, 4 times. Right, 4 times 40 gives me 160. I want 170, so I've got 10 left over. 40 goes into 100 2 times, right, because 2 times 40 is 80. I've got another 20 left over. 40 into 200 is going to go 5 times. With no remainders. So our answer, again, don't forget the decimal point there, our answer is going to be 0.425. And that's the end of converting fractions, decimals, and percentages.